Good afternoon, students. Welcome to my YouTube channel, Applied Science College. Yesterday we went through some questions, titration practical 11, redox titration, and I promised very well that I'll come back to you with the well-solved questions. So today I'm just going to take you through yesterday's procedure, and we see how those questions are supposed to be answered. And before we proceed, please just make sure you subscribe to my channel, you like, and also you share it to your friends, so that we can be able to assist each other, and also you assist a friend to assist a friend. It will be very well, and it is very, very important. And these questions, they usually they are usually set for the Form 3s and the Form 4s, so that they can be able to know how they can solve those questions regarding the redox titration. And initially, we saw the meaning of the redox titration, and we saw why it is called redox titration. So let me just take you to the procedure. This is it is titration practical 11, solving the questions. So without wasting time, I'm just going to take you through the procedure. Let me just read. You are provided with solution G, which is acidified potassium permanganate 7, containing 3.16 grams per liter of solution. Solution H. Solution H is prepared by dissolving 1.47 grams of solid iron 2 sulfate, which has this formula FeSO4n 2H2O in distilled water, and the solution is made to 250 solution. You are required to determine the value of N in the formula FeSO4NH2O. Then we go to the procedure. Place the solution G in a burette. Put 25 ml of solution H into a clean conical flask. Titrate H with the solution G until a pink color just appears. Record the results in the table below. Then you repeat the procedure 2 more times to complete the table below. Let me repeat. Record your results in table 1 below. Repeat the procedure 2 more times to complete the table below. So that is the table. So when we did that practical, we were getting 29.8 as the average volume, as you can see, and we have maintained 1 decimal point throughout. And then we were getting 29 in the first column. We got the volume of the solution G used as 29.5, and then in the column 2, the volume of solution G used was 29.6, and then in column 3, the volume of solution G used, it was 29.5. So we went ahead and calculated the average volume of solution G used. So we took the two values that were very close to each other, which were very close to each other. So we took the values for column 1 and column 3, and then we added them together, and then we divided by 2. So we got this answer. Let me just rectify here. This one is supposed to be 2 by 2, and then we got the answer as the average volume to be 29.5 cubic centimeters. So that one was giving us 1 mark. one complete table with the right figures. It was giving you are supposed to be given 4 marks, as you can see on the table there. And then we went ahead and we were requested to calculate the concentration of the solution G in moles per liter. So we went ahead. First of all, you are supposed to know the formula of potassium permanganate 7, which is KMnO4, meaning that the molar mass is supposed also to be calculated using the given atomic masses that is above there. So potassium, as you can see, it is 39, and then also the manganate is 55, and then oxygen is 16. So, and then we went to an extent by equating that the molar mass therefore is equals to, in that chemical formula, as you know that potassium, it is 39, and then we added 55, as you can see there, 55. Then we placed the brackets because oxygens, they are 4 molecules. So we were supposed first to multiply 16, because the relative atomic mass of oxygen is 16, times 4 because there are 4 molecules, as you can see in the chemical formula up there. Then after you have gotten their products, that's when you will be able to add everything so that we can be able to get the relative formula mass or the relative molar mass. Then we went ahead and added everything together, whereby we were getting the molar mass was 158 grams per mole. Then, as you know that concentration is equals to concentration is equals to mass of a concentration divided by the molar mass. So as we were requested earlier, up there, we went ahead and divided 3.16 over the molecular mass or the formula mass. So because we were requested that 3.16 from the initial equation there, 3.16 grams. It is the one that were dissolved in 1 liter. So we brought that 3.16 there. 3.16 we divided by the molar mass, and we ended up with our final answer as 0.02 molar or mole per dm cubed. So the second question, the part 2 of that question, we were also requested to calculate the number of moles of solution G. So we went ahead and did so. We equated if 1,000 cubic centimeters can be able to give us 0.02. Remember, solution G, it is acidified potassium permanganate from up there, solution G, as you can see there being described from procedure, from number 1, solution G, that is acidified potassium permanganate. So if we mention G, make sure that it is acidified potassium permanganate. So we equated 1,000 cubic centimeters, it was giving a 0.02 molar. What about for 29.5? This is 29.5. 29.5 was our average volume from the table there. It was our average volume, whereby we cross-multiplied 29.5 times 0.02, we divided by 1,000. So our final answer was, we got 0.00059 moles as our final answer. Then, we proceeded ahead and answered part 3 of that question B. Part 3 of that question B, we were told to calculate the concentration of solution H in grams per dm cubed. So we went ahead, we equated This one 4.17. Remember, this 4.17 was being dissolved in only 250 cubic centimeters. What about in 1,000? So we went ahead and cross multiplied that. We took 4.17 multiplied by 1,000 and then we divide by 250 cubic centimeters. So we went ahead. If you do your calculations properly, you will be able to end up with 16.68 grams per dm cubed. Then we went ahead and did also part C. Given that the ionic equation for the reaction is, that is iron 2 iron, then potassium permanganate in ionic form, it is written that way, and then also hydrogen is being, it was also given out. So on the reactant side, as you can see, those ones were the reactants, and the products, those ones were the products. And always remember to be writing the states of each product you get, and also on the reactant side. So this is the reactant side, and on the other side it is the product side. So we went ahead and determined the number of moles of solution H. So we went ahead and said, since we knew the number of moles of G, which was 0.0059 moles, then what about for those ones were in G. What about for H? H now, it was we went ahead and picked from the mole ratio. The mole ratio was 5:1. That's why we are dividing 5 over 1, and then we multiply it by 0.0059 moles, which was giving us 0.00295 moles. Then we also went ahead and calculated the number of moles in 100 cubic centimeters of that solution. Then we said that if 25 cubic centimeters can be able to give this number of moles, what about in 100? Then we cross multiplied and ended up with this number of moles, 0.0118 moles. We went to an extent of also answering question D. Then part 1, it says, determine the relative formula mass of FeSO4NH2O. So, first of all, we need to consider the atomic masses of each element or each atom. So iron, it is 56, sulfur, it is 32, oxygen is 16, and the hydrogen, it's 1. As you can see, the way I've given them there. So you are also supposed to get the mass of the sulfate ion partly of that. So we equated that. Since the valencies of iron 2 sulfate, they are of +2 and -2. So when we write the chemical formula, the 2's are always assumed because they cancel each other in that equation. So there is no need of indicating those 2's in the chemical formula of iron sulfate. So we went to an extent of answering we went ahead and calculated further. Since iron has got only one atom, we added 32 of that sulfur, and then oxygens are 4, that's why we are multiplying it by 4, that is 16 times 4. Then we went ahead and got 152. If you add 56, 32, 64, and then you get 152. So the mass of N water part is N times 2 times 1. We are multiplying it by 1 because hydrogen is only 1. No, we don't have hydrogen in that water of in the water molecule, it is only 1, and then oxygen, hydrogen are 2, and then oxygen is 1. So that's why it's called H2O. So which was giving us N times 2N times into brackets 2 plus 16, which was giving us 8n. Then we went ahead and said the total relative formula is the sum of that part is 152 plus 18n. Remember, 152, it is the relative formula mass of ferrous sulfate plus 18n, because we cannot add everything because we don't know the value of n, we don't know the value of n, but 18, it is the relative formula mass, relative molecular mass of water. Then we were told, last but not least, we were told to calculate the value of n in that formula. So we went ahead and equated the relative formula mass of ferrous sulfate, which is 278, because we always know that that is the relative formula mass of ferrous sulfates. So we hydrated ferrous sulfates. So 152 plus 18. So we took that one and then equated to 278. So we took the like terms together by by putting 152 on the other side. If it crosses the equal sign, it becomes a negative. So we subtracted 278 from 152, and then we got 126. 126, 18n is equals to 126. So for us to get the value of n, we need to multiply each side by 18, and also that 18 can cancel 18, so that we can get 18, n is equals to 126 divided by 18, which was giving us 7. Thank you for listening to me, and remember to subscribe and also to share my channel. And when I will be coming up with more questions and answers as times goes by. Otherwise, thank you for listening to me, and remember to share my channel, and we shall be able to learn more in Applied Science College. And bye bye, have a nice evening. Thank you.